Now, let's go ahead and begin. So first thing I want to address is a lot of you came from computer science principles with me, so you're pretty familiar with while, right? Or at least you've seen while. You remember while. Others of you come from JavaScript, and you remember while from there. Others of you, is it Perl? No, I don't think I have any Perl programmers there, mind. Who had while. So a lot of systems use this while, and this is one of those iterations you're going to see everywhere. So while, you know, in English, means that something, as long as something continues to be true, right? You're allowed to say yes. Yes, thank you. So a while in here is what's called an iteration. And an iteration means that it's going to repeat something as long as it's true. Everything between these two brackets is going to happen, and we'll worry about what that means later. For now, we'll notice it's while some condition is true, this is repetitively done. This is kind of like the what that we learned. What structure is this like with the condition and action? What structure is that like? If, as some people said, and some people put up their hands, as you should do. Very nice. Yes, it's just like the if. In fact, this is a member of three what are called control structures. And I would love it if you kept this in your brains as we're going through it, even with notes or whatever. There are three types of control structures, or at least two kinds we're going to look at today, selection and iteration. This is the iteration, of course. Selection is the if statement. Iteration is the while. If you know it, it's also the for and the do while, which we will go through. All right, so this structure itself, the iteration structure with the while loop, operates like this. While this condition is true, everything between the two brackets is run. So let's go into what is actually happening between the two brackets. Anyway, what's going to happen between those brackets? All right, first thing that happens is it's going to print out this text saying running the program. Next, it's going to do this random thing, and this random thing is really what I think might confuse you a bit, and you might like to talk about. So, what Math.random is it is a, and I'm going to draw this here, Math.random is where it looks at all the time since I believe about 1970 to today. From 1970 to today, counts up all the milliseconds that have ever happened, moduluses them, does a special algorithm with it, and then finally produces a random number between 0 and 0.9999999, otherwise known as 0, and I'm going to type this one out, 0 through 1.0 exclusive. So what does that word exclusive mean? If we're saying it's 0 through 1.0, what am I excluding? What value is not included if I say exclusive 0 through 1.0? What do I mean? Someone told me their hands up. Oh. Almost. Yes, I like the answer. So we might think first, these two are not included. What it means is 0 is a possibility, but 1.0 is not. Specifically the upper bound, we call it. This one's the lower bound, this one's the upper bound. 0 is the lower, 1 is the upper. That makes sense, right? So all the other values that are possible are things like 0.21 or 0.55. That lower bound is included, upper bound is not. So, thank you, good point. The boundaries here, we call them our bounds. It's between the two bounds. Anything between the two bounds is possible. Anything between 0 and 1, except for 1, that's the exclusive, is all possible. So what's the use of that? Because most random numbers you want probably aren't 0.72675. You have a question? Yes, that's true. These are all percentages, and that might be a way to think of this next part. Looking at the code here, Math.random is that thing that seeds by time that we just mentioned. That's going to return a double value between 0.0 and 1.0 exclusive. From there, we usually don't leave it in that value because those aren't very useful values most of the time. So what we do then is we then multiply by a value. In this case, I'm multiplying by the upper bound that I want. I want inclusive 0 through 2, which is also exclusive 0 through 3, meaning 0 is a possibility and 3 isn't. So I haven't changed anything about Math.random. Math.random still returns 0 through 1. But by multiplying that value by a 3, it changes it. It changes it to the point where, let's say, give me a random number between 0 and 1. Give me a random number. I want a really small one, or a bunch of little numbers. Okay, 0.00001. Perfect. I'm going to multiply that by 3. And then I'm going to add 0 to it. And then I'm going to turn it into an integer. What would this become in integer form? 0. So that means my random number is equal to 0 because I multiply it by 3, add 0, and then cast it to an integer. Let's make it a little more clear about what we're doing. Give me another random number, a little small, a little bigger, but still a bunch of digits. 4, 5, 3, 8. Awesome. I'm going to multiply that by 3 because that's the value that's being returned. And then I'm going to add 0. Let's get a slightly larger number, 854. That times 3 produces a 2, right? Turn into an integer. What is it now? What is it, guys? What is it? What does this become? Good. 2. Remember that. Integer truncates, meaning removes all the things after the 0, meaning round it down. Always round down. So that becomes a 2. If that was 0.85 times 3, it returns a 2. Now that is something that I'll talk about later. Now, let's say we get one value. You'll notice that all the values 0, 1, and 2 are possible. For instance, if I did the 0.65, I believe that times 3 gets me to the 1, and then round it down for the 1. So you see 0, 1, and 2 are possible, right? Is 3 a possible value when we cast it to an integer? No, because even if I had 0.9, this one isn't able to. Doubles aren't that big. They're that big. It still would get rounded down to 2. So it gets one of those 3 values. Does it make sense that this is now going to be a random number between 0 and 3 exclusive? I'll address 2 things. 1, how random is it really, and why the plus 0? For now, let's pretend it got the number 1. So we're going to enter this while loop. If random is 1, does it meet the condition? Everyone say it. Yes, because it's not 0. So it's 1. So it prints out running program, and then it randomizes it again the same way. So again, there's technically supposed to be a 1/3 chance that it could be 0, 1, or 2. Let's pretend it's 2 this time. Do we do it again? Do we do it again? It's 2? Yeah. We go back in, change it again. Do I do it again? If my number is 1? Yeah. Now let's say it turns to 0. Do I do it again? No. So we're done. And you'll notice that produces a more randomized program. RNG. RNGesus is helping us today. Now, this first time, I ran it. Did it do anything? Why? Because it got a 0. So I know there are chances where it won't do anything. That's the thing about random. It could go on forever. It could go twice. It could go 0 times. We don't know how long in advance it will go. Exactly. The program loops until it reaches 0 because that was the thing I put there. And you'll notice there are a few things that are necessary. 1, this word while. 2, a condition. 3, that condition has to be possible at some point. So I need a change in there. That's what the textbook calls it, a change. By the way, textbook I'm referencing is Java methods book here, but I also put all that into PowerPoint form on the weekly PowerPoints that are there. So you'll be able to check that anywhere. But yeah, you have the while, condition, and a change. It has to be possible to get to that value. Make sense? Questions? Besides the 0 and the how random is it? Any other questions besides those 2 things? Yes. Now we just said whatever multiplied by is the range. And in this case, it is true that 3 is the upper bound exclusive and 0 is the lower bound, right? But watch what happens if I were to do plus 2. So 3 and 2. Now, in Python, you, from my CSP students, remember that you did a random and it was 2 through 3, right? And that got you a random number between 2 and 3? Yeah, it's a lot easier, a lot more, what? Abstracted. Like we said all the time last year. All right, in this case, it's a lot harder. So we get a random number and multiply it by 3, and then we add by 2. That changes the range in this way. It's no longer 0, 1, or 2. No. It's not that. Instead, it's going to be, what's 0 plus 2? What's 0 plus 2? It's not 2, 3, 4. It's not 234. Go back to math class. 2, 3, 4. So the change that happens, and I'm going to make this a bit easier to read, because now we're doing it plus 2, this is our new range. So you notice that's not the upper bound anymore. It complicates things a little bit. The best way to do this, I would recommend just doing it mathematically and working it out. Start from that 0 times, and then see how you can work it out. So this changes to our bounds. I'm going to tell you now, I want to get one where it's going to be, the boundaries are, let's say, 3 through 40. So the way to start that off is I'm going to make it go 3 through 37 plus 3, which should get me there. Wait. No. 38. Yeah, 38 plus 2. All right, so does it make sense how to get those boundaries in? Yes? It's not necessary to include 0 when you're just doing 0 through like 6, because you don't need the plus 0. But I like putting it in there for the purpose of the same reason why I like having the white space in the program. Tabbing it all out, it's easier to read. But up to you guys. If you really don't want to put it in there, don't put it in there. But I would recommend it. And I, of course, have to change both of these. So we're getting the 38 plus 3. And with that, I now have a 1 in 40 chance to stop. Oh, I have a 0 chance, don't I? I have to move this up to 3 now, right? Yeah. So now I have a 1 in 40 chance of stopping the program each time it runs, right? Is that true or false? It has a 1 in 40 chance of running. Yes and no. It depends how you mean 1 in 40. What is a 1? What is a 40? What is all this stuff? Here's the thing. There's a word I got to get you. And it's a word that just simply explains why you won't need to worry about this too much. Did you guys notice how when we had our 0 through 3 example, how we picked first the really small number, and it was a 0, and we picked then a slightly larger number, and it was a 0, and then we picked a slightly, and then if we went on, we could have picked a slightly larger number, and it finally got up to 1. So you'll notice that the ranges that return things aren't exactly correct. Furthermore, if you had 2 random number generators that start at the exact same time, so it's the exact same number of milliseconds since 1970 or 1971, you'll notice they'll come up with the same answer. So that's not really random. This is what we call a pseudo random. You all know the word pseudo, right? Yeah, it's a pseudo random algorithm. So it doesn't actually return a random number, but it's random enough for our purposes. Let's say instead of saying running program, we actually printed out random. If we actually printed that out, and then we asked you, are these numbers random? Maybe. Maybe they are, maybe they aren't. We don't really know. I can tell you theoretically, they are not. Theoretically, these are not true random, they are pseudo-random. Theoretically, I also tell you that true random is possible when you get down really, really deep into altering it. A fun, great thought exercise, if they ever bring back CSB, I will absolutely do it. But Not something I'm really going to guide you through doing. But yeah, so that's what we're going to do. That's going to be basically the extent of our random, this pseudo-random method that already is kind of complicated. What are your questions? Before we go into guessing game, I want you to look right here at this while loop, right at the condition for the while loop. What do you think our sentinel value is?
38, right?
It's 3. It is what? 3. Good. And sentinel is someone who looks for something, right? It's the value the while loop is looking for, so we can stop running. That's it. Go ahead and get right into guessing game. I'll talk to you next time. Thanks for watching.